Nice. Then for the data preparation, now that you understand the properties of your data, the next step is simple. How do you prepare the data for use? You understand the properties of the data, you understand there are probably some issues that the data has. You need to fix those issues so that the data will become useful for what you want to use it for. That's what we do under the data preparation phase. Does that make sense?
Yes.
Yes.
Next, we can talk about the data modeling phase. Now that you've prepared the data and it's ready for use, you can make use of that data for your purpose. You can analyze it. In other words, you can build a statistical model. That's what we do when we talk of data analysis. Or you can build an algorithmic model, which is what we do under stuff like machine learning. For the purpose of this workshop, we are not interested in this, we are interested in this. This is what we are interested in for the purpose of this workshop. Now, once you've been able to build that model, you've been able to model the data, you have to evaluate the model that you've built. The concept of data modeling is just, I have data, I wish to know what this data tells me about my problem. How can this data help me solve my problem? What solution can I get from this data? Once you've gotten that solution from the data, you need to be able to confirm that the solution actually matches the problem that you are trying to solve. In other words, the model that you get from your modeling stage, it needs to explain your data in the correct way. It needs to have a good correlation with the problem you are trying to solve. That is what we do under the data modeling phase and data evaluation phase. We try to confirm that what the model is telling us is actually correct. I hope that makes sense. Does that make sense?
Yes, it does.
Okay. Finally, once we've been able to confirm that our model is accurate, the next step is to deploy that model. Basically, the idea here is based on the results of your evaluation. If your evaluation is telling you that your model is correct, you can move on to take the accurate steps with the model. If your evaluation is telling you that the model is wrong, then you can go back to previous steps to correct what you have done. Which is why if you look here at this diagram, you find out that the arrows are not unidirectional. The arrows go forward, they also go backward. They go both clockwise and anti-clockwise to show you that sometimes you may have made some mistakes in earlier steps. You can always go back to trace your steps, correct what you've done. For instance, in the process of evaluating your model, you may end up realizing that the criteria you are using to evaluate your model may not match the requirements of the problem you are trying to solve. You can go back to your business understanding stage to fix that problem. You may understand, for example, in your modeling stage, that the data that you are trying to use to model is not well prepared to solve that problem. You can go back to your data preparation stage and fix that issue. Does that make sense?
Yes, it does.
Okay, nice. So for the purpose of this workshop, we are going to be making use of two Python packages. We're making use of pandas, and I'm making use of matplotlib and Seaborn for our analysis. So I will try to be as fast but as concise as possible so that you can have a good idea of how the process works, so that when you have your own data analysis project, you can get started quite easily. Now, I should quickly make a note to you guys. You guys voted in the chat. You voted for the budget and sales analysis data sets, right?
Yes.
That's what you guys voted for in the chat. But I took a look at that data set and I found out that the data set does not contain so much information, which means that it would not really be very suitable for this workshop. So I took the liberty to select a different data set. I selected the data set for heart disease. So we'll be working with the heart disease data set. Okay, is that clear?
Yes.
Is that clear? Okay, nice. So first things first, what do? We need to import our appropriate libraries. We import the required tools and libraries. How do we do that? We said we are going to be making use of pandas and matplotlib along with Seaborn. So we just import them. So we can do this. Import pandas as PD. Next, we import matplotlib.pyplot as PLT. And finally, we import Seaborn as SNS. I run the code. It's running good. Now, let me just quickly make a short change here. Yes, to show the line numbers. So basically, this is just telling Python to load in the tools we wish to make use of. Loading pandas. And instead of calling it pandas, call it PD. Loading this, instead of calling it this full name, call it PLT. It's basically saying Ayomide, also known as AY. That's the basic idea of it. Does that make sense? I hope that makes sense.
Yeah.
My apologies, I have a little bit of a cold. So now that we've loaded in our tools, we need to import our data. So we import the data. So how do we do that? Data equals pd.read_csv. And then we give it the name of the file we need to import, the name of our data. The name of our data is heart.csv. We load in the data. Good, we have the data here. I want us to look at the first 5 rows of our data. How do we do that? We can just do this data.head, the first 5 rows, 5. How many rows do you want to see? The first few rows, how many of them do you want to see? We wish to see 5. We run it, and these are the first 5 rows of the data. Does that make sense so far?
No, please. Can you check the chat? We have some issues.
Okay. Pandas and Seaborn. Nice. So I will explain. Pandas is basically used for data manipulation. That's basically what we use it for here, for data manipulation. Matplotlib and Seaborn, we make use of it for data visualization, to visualize our data, essentially basically to draw graphs with our data. Does that make sense? Does that make sense? Okay, nice. So basically you use pandas to manipulate data. You use matplotlib and Seaborn to visualize data, to draw graphs, to plot graphs, things like that. I'll show you how to do that today. So basically, for the data manipulation, for instance, what we did here is pandas we made use of here. We made use of pandas here. We made use of pandas here to load in our data. We loaded our data here. We made use of pandas to look at the first 5 rows of the data. So now, these columns, these are the columns of our data. What do they mean? Can you see this screen here? Can everyone see this screen here? Talking about the heart disease data set. If you
Yes,
can see it,
Yes.
yes. Can you see all this? The age, the column of the age tells us what? The age. This tells us what? The gender. This tells us the type of chest pain. So CP stands for type of chest pain. Does that make sense? Can you hear me? Or are there any questions?
please, can you come again?
Okay. So in our data set, every column of our data set represents a variable. Are you with me?
Yes.
Yes.
every column of our data set represents a variable. This is the first column. This first column contains the age of our patients. Does that make sense?
Yes.
The second column here contains the gender of our patients. So 1 means the gender is male. 0 means the gender is female. Does that make sense?
Yes.
Make it.
Yeah. This third column tells us the type of chest pain. Remember, we are dealing with heart disease. Someone says, oh, I'm having issues with my heart. I tend to have chest pain because of my heart issues. What type of chest pain are they having? Different type of chest pain are represented using different numbers. They are represented between 0 to 3. So 0 represents one type of heart chest pain. 1 represents a different type of chest pain. 2 represents another type of chest pain. 3 also represents another type of chest pain. Does that make sense? Does that make sense?
Yes. Makes sense.
Okay.
Each number represents different.
Yes, each number here in this column represents a different type of
represents
chest pain.
different. Okay.
Yes. Then this column here is telling us the resting blood pressure of our patients. So what does it mean by resting blood pressure? As you are sitting down now, we are not worrying about anything. We are not doing anything. We are not running. We are not doing any exercise. What is your blood pressure? You are calm. You are calm as you are not under pressure. What is your blood pressure? That is what we call the resting blood pressure. Does that make sense?
Yes.
Yeah. Now, this column here stands for col. Col just simply says, what is the level of cholesterol in your body? So I don't know how many of us are aware of this, but our doctors will tell us not to eat too much fried food, to eat too much fried meat and things like that. Why? Because this type of food are high in cholesterol, and cholesterol can lead to heart disease because they can block the veins close to your heart. I don't know how many of us have heard of this before. Has anyone of us heard of this before?
No, I'm not. Although I know it's too much oily food, it's not good for
Yes,
cholesterol levels.
yes. That is what I'm trying to explain to you. Those cholesterol levels, if you have a high cholesterol level, it can block your veins that pump blood from your heart. And so once it is blocking those veins that pump blood from your heart, it begins to give you high blood pressure, you begin to have heart issues and stuff like that. So this column just tells us the amount of cholesterol that is in the person's blood. I hope that makes sense.
Yes. Okay.
Yeah. So next we have the FBS. FBS stands for fasting blood sugar. So what fasting blood sugar means is the fasting blood sugar is just in the situation whereby you have not eaten anything. So majority of our food is carbohydrates, which means that majority of our food contains sugar to some degree. What fasting blood sugar just tells us is in a situation whereby you have not eaten anything, you've not eaten anything for a while, what is your blood sugar level? You've not eaten anything for a while, you've not taken any Pepsi, you've not taken any Coke, you've not taken anything sugar. What is your sugar level? That is what we call blood sugar, fasting blood sugar. Does that make sense?
Yes.
Yeah. Makes sense.
Nice. Then this column just tells us the results of your electrocardiographic testing. Basically, let's not talk too much about this, but have you ever seen these movies where you have like a electrocardiogram that records the heart rate, the heart rate of your patient?
Yes.
That's basically,
Also,
yes,
American.
Okay. All those
yes,
up and down, zigzag.
yes. This column records
Good
information
doctor.
about, yes, this column records information about that graph. That is basically what it does. Let's not talk too much about it because time is going. Then these columns here, this column tells us the maximum heart rate. How fast is your heart beating? The speed at which your heart is beating. How fast is it? What is the maximum speed? When someone's heart is beating too fast, a lot of the time, it can lead to high blood pressure. So this is asking us, what is the highest speed at which the person's heart is beating? Does that make sense?
Yeah.
Yes. Then this particular column is talking about exercise-induced angina. So what is angina? Angina is just simply put the kind of heart pain that might occur once in a while to people. Once in a while, you are not sick, but you might just encounter some kind of heart pain or chest pain, and then suddenly you are better. It's like sometimes when you are just dizzy, it doesn't mean that you are sick. It just happened like that. It doesn't mean you are sick, but you get better and you just move on. Does that make sense?
Yes.
That is angina. So when you talk about exercise-induced angina just says the angina that you have, that chest pain you have, is it because you were doing exercise or not? Because sometimes when you're lifting weights or you are running, when you run for a long time, you need to have chest pain. It doesn't mean that you have heart disease necessarily, right? It's just a side effect of the activity you were doing. I hope that makes sense. Makes sense?
Yes, it does.
Yes.
Makes sense.
Yes. So if the angina you have, the chest pain you have it because you were doing exercise, then that means the value will be yes. And yes is equal to what? 1. If the angina you have it and you are not doing any exercise, then the value will be no. And no is equal to what? 0. Does that make sense? I hope it does.
Yeah, makes sense. Yes.
And this column here is just talking about the ST depression. Essentially, ST depression is when your heart rate goes very low. It goes below the regular limit. Everybody has the regular limit, the average heartbeat, average rate of heartbeat, right? I think the human heart beats on average about once or twice every second, if I remember correctly. So if that heartbeat, or rather the rhythm of your heartbeat goes too low, below that average, we call it an ST depression. Does that make sense? So this column here is just telling us how low did that heartbeat, how low does it go below the limit, below the average. I hope that makes sense. Does that make sense?
Yes.
Now, this process that we've done here now, where I was explaining all these columns to you, this is part of what we call our data understanding. Does that make sense?
Yes, makes sense.
Does that make sense now? So this is part of what we call our data understanding. So as it stands now, our data understanding is done. Does anyone have any questions? Basically, you just have to understand what your data is talking about. Does that make sense?
Yes, makes sense.
Now, I went out of order.
Data understanding, it's okay.
Yeah. So this data understanding, but it's not done, it's almost done.
What
Now,
did you say about target?
yes. So the target is telling us, whether the person has heart disease or not. Are you getting me? The target
Something like the output or something like
yes,
that, right?
yes. Based on all this information that we have about that person, did you do exercise? Is your angina due to your exercise? Based on all this information, we now know if the person has heart disease or not. If the person has heart disease, the value is what? 1. If the person does not have heart disease, the value is what? 0. Does that make sense?
Yes, it does.
Yeah,
Thank you.
It does.
Makes sense. Yes.
Yeah.
So the basic idea still applies to these last two columns, but to save our time, I want us to skip these two columns. We have just about 20 minutes to go. So that's the basic idea of it. You can always look this up. You have the link. You can always look it up. Maybe do a little bit of browsing to understand it better. So now our business understanding is very simple. What are the questions we want to answer? So based on this data we have now, can you guys give me some kind of suggestion on the questions you want to use this data to answer? Give me some kind of suggestions. Questions of interest.
Okay. I think one. What state was the person when he had the heart attack?
Okay, heart attack. Okay.
Yes, like what was it? What was the person doing at that point before the heart attack? Is he exercising or he was just resting?
Okay, that is a very good question to ask, but our data does not contain that. The
Okay,
data does
we
not
can.
tell us.
Okay, but you explained something about Ajina.
Yes.
Then you
Yes.
explained something about resting. There's a point there about rest. When you are at rest, your heart rate is
Yes. That information is already here. We know this person was not exercising. That means when the value is 0, we know that the person was not exercising at all. The angina was not due to exercise. So that question is already answered here. Does that make sense?
Okay.
That question is already answered here. So to save our time, we can ask some questions. We can say,
Okay, can we
what?
ask this data? Can we ask data how does smoking correlate with heart disease?
Okay, yes, that's also a good question to ask. That's also a good question to ask. But we don't have any information on smoking here. There's no information on smoking here. So we will not be able to answer that question. Do you now understand why I said you need to understand your data to be able to ask the right questions? Because our data does not tell us
the other
anything
question.
about. So we can say, first
Okay,
question, we can say,
age.
what gender is more likely to have heart disease?
You can
Right?
also ask, does age, if age has an effect to having the heart
Okay.
disease?
Okay.
Or what?
Okay.
Or at
Age.
what age is one likely to have heart attack or heart disease? I think that's
Okay. Okay. Yes. What age is
Prevalence
more
of
likely?
the age, yeah.
Okay, we can say heart disease is more likely to be prevalent at which age? That is a good question. So there are other questions we can ask, but in the interest of saving our time, because we only have about 15 minutes now, I want us to just focus on just these 3 questions alone. The goal here is not for you to master how to write the code. The goal here is for you to have a good idea of the process. If you understand the process, learning how to write the code will not be your problem. But if you don't understand that process, no matter how good you are at writing code, if you don't understand the process, then you don't know what you are doing. I hope that makes sense. It doesn't make sense. Doesn't make sense if you know how to shoot a gun, but you don't know the enemy you are supposed to be shooting. Yeah. So we'll focus on us answering these 3 questions. This is basically what you do under your business understanding. What are the questions that I'm interested in answering? What are the problems I'm interested in solving? That is what your business understanding is all about. I hope that makes sense. So this is done. For now, this is done. Basically, we can make things more complex than this, but the idea is for you to have a good understanding of the overall process. So now these are the questions we wish to answer. We've already done our data understanding to some degree. What else can we do under our data understanding? We can check. We can check for missing values. Are you following me? We can describe the data. These are just two of the simple things we can do under data understanding. So let's check for missing values. How do you check for missing values? Very simple. Data.isNA. NA means not available. .sum. That means it's going to tell us how many missing values are in each of those columns. So each of those columns, under age, 0 missing values. Under sex, 0. Under chest pain, 0. Everything has 0, 0. That means that there is no missing values. Does that make sense?
Yes, it does. Yeah, it does.
There are no missing values. There are no missing values in our data, so our data is complete. Okay. Our data is complete. There are no missing values. We can describe the data to give us an idea of what is going on in the data. So describe the data. How do you do that? Data.what? Describe. I run this, and this is a description of our data. Count. For this column, count tells us how many values are in this column. Am I making sense? Am I making sense?
Yes, go ahead.
Yes. The mean is telling us what is the mean of this column. So the mean of the age, the average age is what? About 54 years. Am I making sense? The standard deviation of the age is about 9 years. So give and take, most people are falling within the range of 9 years lower than 54, 9 years greater than 54. So 54 minus 9, that is 45 years. So 54 plus 9, that's 63 years. So the people most of the people in the data are falling within the range of 45 to 63 years. Basically, roughly speaking, that's the idea of the standard deviation. Does that make sense? Makes sense?
Yes, it does.
Yeah, it does. Yes,
Now,
it does.
yes, we now see minimum. Minimum is telling us what is the smallest value here. The youngest person in our data is what? 29 years old. The oldest person maximum is what? 77 years old. That is basically what we get from that. Are you with me? We know that 25% of the people in our data are within the range of 29 to 48 years. We know that 50% of the people in our data are below 56 years. The remaining 50% are above 56 years. Does that make sense? The same idea applies to this. So this is what we call, these are what we call the percentiles. So this is something you can always do some more research on. Note, you can do some more research on quantile or quartile and percentiles. You can do some more research on that to understand these values better. But our time is going, so let's be as fast as possible. So you can use this based on this table alone. We have some understanding of how the age is distributed. We know that the average age is 54 years old in our data, right? Does that make sense? And we can even decide to visualize the age. Let's visualize the age. So we visualize the age. So we can do this PLT, or we can do this SNS dot dist plot. Data equals data. Y equals the age. PLT dot show to show the graph. We want to plot the age in the graph. Does that make sense? Or we can just do this PLT dot ADE plot. There are different ways to do this. Just do this. Let me change this. Yeah. Wait a minute. Oh, sorry. Sorry. Yes, just for the histogram. So you can see that the maximum age is somewhere around here, somewhere around close to 50. Close to 50. Does that make sense? Does that make sense? Let me see. Yes, it looks better now. Does that make sense? So on the x-axis, we have the what? The age. On the y-axis, we have the what? Age, frequency. So we have the age and the age frequency. I hope that makes sense so far. I can't hear anybody. Does that make sense?
Yes.
Okay. So based on this visualization now, you can see that the maximum age is somewhere around here, somewhere within the range of 54 to 60, which we know here from our data that the average is what? Is somewhere around 54 also. So we know that our data is relatively normally distributed. You can look into what we mean by normal distribution later. Let me just add that here. Look into normal distributions. I'll make sure I send this code to you guys. Okay. So basically, this is an idea of how to carry out your data understanding. Just play around with your data, describe the data, visualize the data to see something about the data so you can understand what's going on with your data. So as it stands now, from this now we can say results. We can say that the most popular age in the data is around years. Okay, basically that's the idea of your data understanding. Understand your data and then try to figure out what the data is telling you. Does that make sense to you guys? Hello? Does that make sense?
Yes, it does. It makes sense.
Okay.
Are we allowed to ask questions now? We should just wait till the end of the class.
You can ask now so you don't forget.
No, I won't forget. I will not want to distract you, but I won't forget.
Okay. Okay. So the next step now is your data preparation process. What your data preparation process talks about is just simply put, any problem that you observe, if you are observing any problem during your data understanding process, so let's assume, for example, that we observe that some of our data is missing. Under our data preparation process, we will fix those problems. Does that make sense? So assuming, for example, now some of our data was missing, we know that our data is complete here. But assuming some of this data was missing, we have to fix that problem. It is under our data preparation here now that we will fix that problem. But our data is not missing. We don't have any issue with data. So our results, no issues with the data. Does that make sense? Does that make sense? Hello?
Yes.
Okay. So, however, I should mention that this is unusual. This is unusual. Most real world data will have some issues. Most real world data will have some issues. So this is very unusual. Most real world data, they're probably going to have some kind of issues. So take note of that. There are other ways to fix issues in data. So you can look into imputation methods. So I'm adding this here so that you can have some idea of what to look into, things to research on your own later. Okay, look into imputation methods, transformation methods, e.g. normalization and standardization. We don't have enough time to talk about all these things, so I'm trying to add in some notes to the code so that you can know what to look into later on your own. So once you've prepared your data, the next step now is to model the data. And then it is in this modeling stage that we now answer all those questions that we have. So these are the questions that we have. Where are they? These are the questions we have. It is under the modeling stage that we will answer these questions. So what are the questions we want to first answer? Which gender is more likely to have heart disease? So let's come here. So this is what we want to do now. Question 1. Which gender is more likely to have heart disease? So how do we know the gender that is more likely to have heart disease? Step 1, get all the people with heart disease. Step 2, what do we do? Divide them by gender, e.g. male or female. Step 3, what do we do? We visualize the results. So how do we do that? How do we get all the people with heart disease? So now, if you go back to this data set, we know that the target, this target here tells us those that have heart disease, those that don't have. Anywhere the answer is 1, we know that they have heart disease. So all we simply need to do is pick out the rows where the target is equal to 1. How do we do that? Heart disease equals what? Data dot log, locate where? Data target equals 1. So anywhere the target is equal to 1, we'll pick out those people. So if you run it, we'll pick out the people that have heart disease. Are you with me? So if we check the data now, we look at the data now, this is the data of all the people that have heart disease. Look at them, their target is 1, 1, 1, 1, 1. Does that make sense? Okay, makes sense.
Yes, makes sense.
Good. Now we want to divide them based on their gender. Based on their gender. So what do? We group them. Group them based on gender. So we can check and we can say heart disease dot what? Sex. Then we count them. We count them. So we'll count them. You see that if gender 1 has what? 300 people with heart disease. Gender 2 has what? 126 people with heart disease. And we know from our data sets here that what? We know from our data set that what? 1 is equal to what? Male. 0 is equal to what? Female. Does that make sense? Does that make sense?
Yes.
The video is skipping some part. I don't know why if it's just my side or I don't know.
I think it's the internet connection. It's internet connection. So how do we convert this now from 1 and 0? How do we convert it now? We can do this. We can replace them with a male and female. So we can say this dot map. We can map what? 0 to what? Female. We can map man to what?
Male.
Sorry? Oh, what am I doing here? Okay. Map, okay. We can, okay. Let me just change this then. Lambda X. Female, if 0, else, male, it should work. So, yes. What the hell? What the, okay, there's a problem here. If X, sorry, equals 0, yes. Yes, works now. So for the male is what? 300. For the female is what? This. So how do we visualize this now? We can visualize it like this. How do we visualize? We do PLT dot what? Is this. PLT dot what? Show. Now and behold, this is it. Or we can do this. Count plot. What the hell? Okay.
I use another visualization like maybe pie charts.
A pie chart. Yes, we can do that. But pie charts are not the best way to plot this kind of data.
But it's just two categories now, just male and female.
We cannot convert string to float. This will not allow us to plot the data because it's expecting a number, not text. So
okay.
expecting a number, not text. So what we can do here, we can just use our count plot. SNS. This would be working, but for some reason it doesn't work. It doesn't work. It should be working. Okay, you know what? We can do a bar plot. It's still not working. Then I've changed that data. That's the problem. I've changed the data. Okay, but do you understand the point I'm trying to make? Now we know that the men are more likely to get heart disease than the women. Does that make sense?
Yes.
Okay, so I would take some time to fix this before I send you the code. I will take some time to fix this before I send you the code. I think the problem is I've changed the data. That's why I'm getting errors, but I'll fix this and then I'll send the code to the chat. Yeah, so for the first question now, we know the result of our first question is this. What's the result? Men are more likely to have heart disease. And if you know your research, for those of you that follow health research, this is actually true. This is actually true. It's true, actually. If you do your research, you find out it is actually true. This result of our analysis aligns with reality. Men are more likely to have heart disease for a number of reasons. One of them is due to the fact that men generally tend to do more stressful jobs, and they also generally tend to smoke more than women. So there are a bunch of reasons, but basically, yes, men are generally more likely to have heart disease. Am I making sense?
Yes.
Yeah. So that is the first question.
Yes, you are making sense.
Good. So for the second question, how does age correlate with heart disease? Okay. So the second question. How does age correlate with heart disease? So to check the correlation between age and heart disease, we can do something called correlation. So we can do this. Do you know what correlation is? Does anybody know what
The
correlation is?
the relationship between two variables.
Relationship.
Yes. So we can check for the correlation. How do we do that? Data dot what? Core. What type of correlation are we looking for? Are we looking for Pearson's correlation or Spearman rank correlation? For the purpose of this discussion, we are
Yes,
going to
sir.
use Pearson.
Yes, sir.
I'm going to use Pearson. If you run this now, it will tell us the correlation between all the different variables. So the correlation between what? Age and heart disease. We know that the correlation between age, this is age here. So we look for age and we look for target, which is heart disease. You see that what? This is their correlation here. This is their correlation. This is their correlation. Do you see it? So what does this value tell you?
It has a negative relationship.
There is a negative relationship between the outcome, the age, and the
And the target.
and the target. Yeah.
Yes. So what we can do now is we can say something about this. Are you with me? We can say something about this. We can say that overall, the age and the likelihood of the person having heart disease, they don't necessarily exhibit a very strong relationship, but the relationship is there to some degree. So we know that a strong relationship requires a correlation of about 30 to 50. But this relationship is less than 30. So the relationship is there, but it is weak.
It's not strong. It's weak. Yeah, weak relationship.
Yes, relationship is weak. So you can look into other ways of checking this relationship, but our time is going. So I don't want us to spend too much time here. If you have questions, you can send them on the WhatsApp group. Okay, does that make sense?
Okay.
Yeah. So the final question that we have is this. Heart disease is more likely to be prevalent at which age? So in other words, which age does it seem like people have heart disease the most? Which age do people seem to have that heart disease the most? So this is a very fast one. We'll do this and we'll be done. So what we just simply need to do now is we'll check the age of people with heart disease. So heart disease dot what? The age we count. You run this. Lo and behold, the age where people have heart disease. Which age does it seem that they have heart disease the most? Age 54. Does that make sense? So we just get what? Can you see it? Age 54. So we can order it, we can sort. Sort by what?
Ascending.
We can sort, sorry? Oh, series. If a series doesn't have sort. It's a series. Okay, yes. Sort equals what? True. So it's a sort of, you can see that it is people at the age of 54, they seem to be having the highest cases of heart disease. Does that make sense? I hope that makes sense. Now, in the real world, we're not just going to stop here. We have to do some more analysis to figure out the reason why it's happening like that. Do some more analysis to confirm our theory. But time is gone for now. This is after 8. So I would like us to round up for now. Then all that's really left to talk about is the model evaluation and the deployment. So I want us to we'll try and fix another meeting to complete this, and then we'll deal with your questions in the next meeting. I hope that makes sense.
Can I ask my question now?
Yes, ask. Time is going, so you can ask now before.
Okay, I was not in the last class. I don't know if you pointed that out. But I went through and I saw that you use VS Code on majority of them. And the question I
Yes.
wanted to ask now, I see that you're using Jupyter Notebook, but I wanted to
Yes.
really know how on the libraries you imported before we started this work, how are we to know exactly the libraries we're going to use for analysis when we have a data set already that we want to bring import into our
Just
Jupyter
let me
Notebook? How which libraries we're supposed to import to work with?
Hello? Hello?
Did you get me? Hello, did you get me? Hello, can anybody hear me?
I can hear you.
Like Benedict is no more here.
I think we lost him.
Mr. Peter, are you there?
Maybe we should just leave the question for next class. Hello?
It's all right. Yeah, thank you.
Yes. Yeah, since we lost it, I don't know. Maybe we should just leave it for next class.
All right, all right, all right. So it's a wrap now, B.
Yeah, it's rough. He's not here. So I think. All right now.
Adios. Buenas noches,
Adios.
everybody.
Good night.